Welcome to the Behavioral Finance Dialogues video series. My name is Gulnur Muradoglu. I'm a Professor of Finance and Director of Behavioral Finance Working Group. I work for the School of Business and Management at Queen Mary University of London. Today, I will be speaking with my colleague, Professor Richard Sias of the University of Arizona. We will discuss stock market beliefs and your beliefs. What is the likelihood of dying from swine flu? If you enjoyed this video, please share it and subscribe to the Queen Mary University of London YouTube channel. And please come back and listen to the other talks in the series. Hello, Rick.
Good morning, Gulnur. How are you? Well, I guess not morning to you. Morning to me.
Good morning to you, yeah. And good morning, America, too.
Yeah.
Nice to see you. So I'll start straight ahead with the
I grew my
question.
corona beard.
You have a corona beard and you have a almost corona paper as well.
That's right.
That's right. So it couldn't be timelier, any timelier than this. Did you have any idea about corona coming on when you were working with the swine flu?
Yeah, we were working with this data on another project, and then I saw that they had swine flu data in there as well. So this was after corona started. So, we just decided, I was already so familiar with the data that we decided to kind of look down that road and see what was there.
Excellent. Okay, so what do you see in the swine flu case? Are there any lessons that we can learn for the corona crisis?
So, well, what we're really doing in this paper is we look at what's called the negative expectancy bias, which is that people tend to focus on the worst possible outcomes, right? That
True.
Yeah. So if you look at people, if you ask people, what are the chances the stock market goes up in the next 10 years? The typical individual, the median individual, reports this is a 50-50 chance the market goes up in 10 years. Empirically, that's like 93%. So people are way too bearish, right? So we use the swine flu as kind of a test of the negative expectancy bias. So what we do is we ask people, they ask people, what do you think your chances are of dying from the swine flu? And the typical individual, the median answer is like 5.5%, which is way higher than what it is. It's about 275 times higher than the actual value, which is 0.8%. So the interesting part to us is saying, okay, if the swine flu, if your expectations about dying from the swine flu are a reflection of your negative expectancy bias, then your expectations for swine flu will relate to your expectations for the stock market. And that's what we find. The people that think they're more likely to die from the swine flu are also much more likely to think that the market will have a negative return, that the market will crash. And they feel that way about the stock market, both in the short term, so over the next year and the next decade. And they feel that way about their home values too. We also have, they also ask people about what do you think the chances are your home value is going to increase, at least for homeowners, they ask this question. And we see the same thing there. People that think they're more likely to die from the swine flu are also more likely to think that their home value will not increase in the next year or 5 years. And they ask these questions both before the discovery of the swine flu, so we know it's not swine flu causing their expectations, right? And after. And it doesn't matter if we measure people's expectations about markets either before the swine flu or after the swine flu, you see the exact same pattern.
That's really very interesting. Do you know if anyone is measuring the expectations?
So they are. So our data is the American Life Panel data, and they are surveying. So with their American Life Panel data, they're actually surveying people about COVID as well. Unfortunately, their surveys are embargoed for a year. I think part for security reasons and identification of people and stuff like that. But hopefully, after a year, we'll be able to add that data to the paper. So it's kind of interesting though, because COVID. If you ask, I think, I don't know, I'm close to 60, so, close to a high risk group here, and 60 is a number, I realize, but it's, kind of the way I feel like, if you ask me what I think my chances are dying from COVID, I probably, even knowing what I know, overestimate it, right? So the Center for, I think it's Empirical Medicine or Evidence of Medicine at Oxford actually estimated the infection fatality rate. So the infection fatality rate is the rate that we really want to know, which is if you get the disease, what are the chances you'll die, right? Their best estimate for COVID is about 0.1 to 0.41%. So, think if it's a 0.41%, think 1 in 250 die from it, which is pretty bad, right? Regular flu, maybe 0.1%, maybe less than that is the infection fatality rate. Swine flu, the infection fatality rate was 0.02%. But what we tend to hear in the media, of course, is the case fatality rate, which is a different number. That's the people who are diagnosed with the disease who actually die of the disease. But of course, case fatality rate, to be diagnosed, you have to have symptoms. So A, we only test people who are symptomatic generally, right? And B, in this particular case, tests are limited, in many countries. So we're not even testing people who are symptomatic in all cases, right? If there's limited tests, especially at the beginning, only people who are highly symptomatic. So if you only test people who are, already really sick, many of them are going to die. So you get your case fatality rates. I think in the UK that the Center for Evidence-Based Medicine is putting the case fatality rate at about 13%. Which is huge compared to an infection fatality rate estimate of, maybe at the maximum 0.41%. So people, I think, hear about case fatality rates and then infer infection fatality rates, which are, a completely different thing.
That's correct. And, I'm good in my statistics, but I still find it very confusing to understand the several ratios. It's very difficult to understand the case and what the comparison is made to. And it's very difficult to absorb when the numbers are given, like 1, 30, 30,000, etc. Because that perception is kind of like escalates the probability that you give to the possibility that you can die. And we know that, in general, people overestimate the small probabilities, and in general, they underestimate the large probabilities. And sometimes I think maybe the probability of, let's say, a job loss due to the crisis, or the probability of the crisis going beyond the 15% that the Bank of England estimates now, etc., much understated, while the probability of death from the virus is overstated.
Yeah, no, I agree. And, from our standpoint, what we find really interesting about it is that, obviously, variation in your and my view of the likelihood of dying from swine flu has no impact on what the actual market return is going to be. You and I, the market return is the market return, right? So really, the fact that I think I'm more likely to die from swine flu than you do clearly doesn't impact, the market return. Yet, given that I do feel that way, I end up, thinking there's a worse market return. I think the other thing that's kind of interesting about it, and I think you kind of touched on this, Gulnur, is that it's not only us kind of estimating, which we think of kind of like an availability bias or something like that we think of these worst case scenarios are so easy to think about, but it's also that we estimate even kind of the average case as too bearish, right? We think it's, it's not uncommon to have the market go up. I mean, that's the most common thing, yet people way underestimate the likelihood the market goes up. And, again, that's more this negative expectancy bias than it is an availability bias. At least that's what we're kind of thinking. So kind of the interesting thing on this paper for us is being able to use something that, is completely unrelated. It's certainly your probability of dying from swine flu, the expectations of that, and your expectations of the market prior to the existence of the swine flu, are clearly independent, right? I mean, yet they're highly correlated.
Yeah, that's true. That's true. I wonder, this time, the stock markets reacted very sharply, almost about 30% drop, both in the US and in the UK. And I'm wondering the expectations there that were formed, with the information of the coronavirus, were they underestimating? Were they overestimating? I guess we're going to know next year. But
yeah, it's been a wild ride, right? I mean, 30%. So the U.S. basically think of about 30% drop with a 30% rise, but of course, going from 100 to 70 is not the same as going 70 to 85, right?
Yeah, that's true.
So we're still down quite a bit, at least in the U.S. I personally have been surprised by how quickly we've rebounded because clearly there's a lot of uncertainty still, right? I mean, I think that, and this was very different than the swine flu episode. I mean, swine flu, it was clear immediately that it had very high morbidity rates, that it was very contagious, but immediately clear it was not very deadly. COVID, I think, is more, it is certainly, more deadly. And it appears to be, the other part of it is appears to be really highly contagious, right? So, I mean, kind of the number of deaths is a function of both how contagious it is and how deadly it is.
That's correct.
So COVID is, significantly worse than swine flu. Actually, swine flu is kind of an interesting experiment because it turns out the mortality was so low. Right? COVID is different. So, it's hard to say kind of people are overreacting or underreacting to that. My guess is people are I'd be shocked based on what we see now that if people aren't overestimating the likelihood of actually dying from COVID. If you ask the general person kind of, what do you think the likelihood if you got COVID, you'll die? I think those numbers are going to be too high. I mean, 275 too high for swine flu. And just based on the things we talked about, that the fact that, the numbers you hear are typically case fatality rates instead of infection fatality rates. And, we're not experts in that area. So, we don't really differentiate what they're talking about. Just hear that, 10% of the people who get it die. That sounds really scary. And it is. But, if that's hospital case fatality rates, that's something different than, if it's symptomatic case fatality rates, if it's infection fatality rates, those are all different numbers.
That's true.
And I think, that's one of the other things. Yeah, I think that's one of the other things that makes it so interesting, because I think people's view of kind of not understanding those differences are also similar to people's views of not understanding the market, right? I mean, the market is very confusing for many people. So it's kind of this, all this ambiguity. So we think, really the negative expectancy bias, psychologists believe it really comes from, a better safe than sorry heuristic that, back when we're developing as humans, that, it's better to impound bad information quickly, right? And be safe than sorry. And we just haven't, outgrown it. That's, it's just part of our nature.
I think so too. It's part of the nature, but it's very striking that expected death rates, at least in the swine flu, were 375 times more than the actual. I mean, that's a number, 275 times more.
It's a big number, yeah.
I mean, it's a big number.
So we also, I mean, the other ones we looked at, just because it was just kind of as a robustness test, was they also asked people a few years earlier about probability of dying in a terrorist attack. So it's surveys of Americans. And of course, people think that in the US, since 9/11, we've averaged one terrorist death a year, one death by a terrorism attack a year. So essentially, population, say 300 million, you have a 1 in 300 million chance, right? Again, the median estimates there are something like 5% chance over 1 year and a 10% chance over 10 years, right? I mean, they're just literally millions of times greater than the actual historical probability that people just, overestimate these really, it's especially bad for, as you point out, really rare events.
Yeah, and again, I don't exactly remember the rates, but there's a similar picture for plane crashes and dying in a crash. It's a very rare incidence, and the death probability is extremely low, but people estimate the probability in multiples. Yeah,
that's right. Same thing with shark attacks. That's another kind of classic example, right? That I mean, you're much more likely to die driving to the beach than you are getting in the water and dying from a shark attack.
Is there anything that you have seen to kind of like de-bias those expectations?
I mean, one thing we've looked at is we actually ask, so one of the things is that the negative expectancy bias is certainly related to mental health. So for example, people that, I mean, many mental health issues are grounded in negative expectancy bias, right? Anxiety is kind of a tendency to think worse things are going to happen and stuff. So we actually find a strong relationship between those measures of mental health, like, you know, and just self-reported measures. So how often do you suffer from anxiety type things, and your expectations of market returns and your expectations of dying from the swine flu. So we see that, right? So people that have better mental health, you know, suffer less from a mental health issue like anxiety or depression, you know, they have more bullish expectations, and generally seem more willing to update their priors. We also kind of look at learning in this study. And when I say we, I should also note my co-authors on this are Harry Turtle and Laura Starks. So I'll blame them if there's mistakes. But you know, we do look at learning. So we look at people, how people's expectations of the swine flu change over the swine flu epidemic. So when the swine flu very first starts, it breaks out in Mexico in the middle of April 2009, and the last week of April, 47% of news coverage in the U.S. is about swine flu. So there's this huge risk of this huge swine flu shock. Because the initial mortality rates coming out of Mexico, which is a very small sample, was about 8%, which is, you know, huge, right? I mean, the 1918 Spanish flu, which of course is the big one, right, had an infection fatality rate of about 10%. So we're thinking, you know, initially, you know, is this the Spanish flu? So it's huge media coverage. And then, you know, within a month or so, we know it's not very deadly, right? I mean, it's spread widely. We're testing for it now. We can see it's not very deadly, although, you know, it's obviously killing some people. So we look at how people's expectations of dying from the swine flu change over time. And we find that those people who seem to be better at learning, more willing to update their priors, also tend to have better expectations about the stock market, that they seem to have updated their priors on the stock market as well. So we do see, you know, kind of you know, there is this cross-sectional variation in learning, our willingness to update our priors, and expectations. So we kind of pulled that out of it too.
Do you also have did you also test for the extent of coverage in the media and the extent of overestimation of the probability?
So we tried to. So yes, so we do find a relation there as well. And so it's a rough test, but basically about 2 years later, the American Life Panel asked people, how much time did you spend watching TV today? So we basically take that as a proxy for kind of the, you know, their media exposure. So it's, you know, it's not measured at the same time, and it's, you know, it's a smaller sample and everything like that, but we still find a very strong relationship. People who watch more TV have a much higher expectation that they're going to die from the swine flu.
I think it's very interesting.
Yeah, it's kind of a fascinating study.
Yeah, thank you very much, Richard.
You bet, Gulnur. It's good seeing you.
Thank you. Good seeing you too. Thank you.
Okay, bye-bye.
Bye-bye.